Very good morning to all. My name is T. Rajita, lecturer in ACE, Government Polytechnic, Mamnar. Now I am dealing with third semester subject, network analysis. Now I am going to discuss about the superposition theorem. In the last classes, we discussed Thevenin's theorem, Norton's theorem, and the maximum power transfer theorem, and reciprocity theorem. Now we are going to discuss this superposition theorem. So, last class we discussed various networks theorems, how to find Thevenin's equivalent voltage and resistance, and draw the Thevenin's equivalent circuit usage, and similarly how to find out the Norton's network, Norton equivalent resistance, Norton equivalent current source, and Norton equivalent circuit. On completion of this period, you would be able to know about superposition theorem and solve some problems on superposition theorem. And we know the limitations and advantages of the theorem. Superposition theorem. See the statement. In any linear and bilateral network containing two or more sources, the response in any element is equal to the algebraic sum of responses caused by individual sources acting alone. See, I am repeating again the statement. See here. In any linear bilateral network containing two or more sources, the response in any element is equal to the algebraic sum of responses caused by individual sources acting alone. While the non-operating voltage or current sources in the network should be replaced by its short circuit and open circuit across the terminals respectively. Means voltage sources are short circuited, current sources are open circuited across their terminals. See here, for example, just I am explaining this superposition theorem with the help of one example. Here, some linear network, and it is this network containing two sources and three circuit elements. The two voltage sources, that is 30 volts and 54 volts, are applied simultaneously to the circuit. Now we want to find out the current in 15 ohm resistor. Just I took a simple problem. With the help of this problem, I am explaining the superposition theorem. Here, two voltage sources are applied. A simple network, that is T-type network, that is 10 ohms, 30 ohms and 50 ohms are connected in T-type network. And in this we have, what is the problem, that is 15 ohms resistor. What is the current in 15 ohm resistor? See here, according to the theorem, we have to short circuit the one of the voltage source and we have to find out the current. So now first short circuit this one voltage source, and here 30 volts are there. See, then the equivalent circuit becomes 10 ohms plus 30 ohms is in parallel with 15 ohms. So the equivalent circuit becomes 30 ohms is in series with 20 ohms, because 30 ohms and 15 ohms becomes parallel, and here there is a result is 10 ohms, and 10 ohms and 10 ohms is both are in series, and the resultant resistance is 20 ohms. See here, 30 is in parallel with 15 plus 10, it equal to 20 ohms. Now the current IT, total current, is equal to 30 by 20, that is 1.5 amps. The current flowing through this I1, total current is 1.5 amps, and the current flowing through 15 ohms is IT into 30 divided by 30 plus 50. So 1.5 into 30 divided by 15 plus 30, that is 1 amp. See, again I am telling this I1, IT is equal to 1.5 ohms, that is through 10 ohms resistor, and we want to find out the current in 15 ohm resistor. So that is the reason now this IT into 30 divided by 30 plus 15. So that is equal to 1.5 into 30 divided by 45. So that equal to 1 amp. So due to this 30 volts voltage source, the current flowing through this 15 ohm resistor is 1 amp. Now in the second case, now current through 15 ohm resistor when 54 volt source alone present and 30 ohm volt source is short circuited. This is the circuit. Here 30 volts source is short circuited and 54 volts voltage source only applied. And now we have to find out the current through 15 ohm resistor. So this 30 volt source is short circuited, so that the resistance is equal to 30 plus 10 ohms into is parallel with 15 ohms. See here, RT is equal to 10 is in parallel with 15 ohms plus 30 ohms. So how much it is? 10 into 15 by 25 plus 30, that is 36 ohms. And that is the resistance. Now the current flowing through total current, that is 54 volts, is applied across 36 ohms. And the total current IT is equal to 54 by 36. See, the total current IT is equal to 54 by RT2, that is 54 by 36, that equal to 1.5 amps. Now what we have to find out? The current through 50 ohm resistor. Now the current through 15 ohm resistor is equal to IT2 into 10 by 25. So that is 1.5 into 10 by 25. So that equal to 0.6 ohms. So what we are getting? Due to the 30 volts voltage source, the current flowing through 15 ohms is 1 amp. And due to the 54 volts, the current flowing through 15 ohms is 0.6 amps. These two voltage currents are flowing through the 15 ohms resistor individually. Now by applying superposition theorem, we are getting the total current flowing through 15 ohm resistor is equal to I1 plus I2, where I1 is the current flowing through the 15 ohms due to the 30 volts by short circuiting 54 ohms source, and where I2 is the current that is flowing through the 15 ohm resistor by short circuiting the 34 volts and due to the 54 volts source. So that is equal to 1 amp plus 0.6, that equal to 1.6 amps of current is flowing. So according to superposition theorem, we have to short circuit one voltage source and we have to find out the current and individually, and sum of this individual currents is equal to the when all voltage sources are applied simultaneously. This is the theorem. See, take another problem. We check in this. Here there is some voltage source and there is a current source. Both are different things are there. So find the current through RL. So RL is 5 ohm resistor and 15 ohm resistor, both are in series. A voltage source and 40 ohms resistor is there, it is in series, and a current source 4 amps current source is there, it is in parallel with 5 ohm resistor. This is the given circuit. So now solution. This replace for a current source with voltage source by 20 volts. How it is? There is a current source is in parallel with 5 ohm resistor. In this we are source transformation, we have to apply that. The source current source can be replaced by a voltage source in series with some resistance. So the voltage is nothing but 4 amps into 5 ohms, that is 20 volts, and it is in series with 5 ohm resistor. So then the circuit becomes easily. Now you can easily solve the circuit. See here, 20 volts with 5 ohm resistor and 15 ohms is in series. Now 25 ohms, volts, 40 ohms. So again a T network is formed here. See there, like this, there is a T network is formed because a 5 ohms plus 15 ohms becomes 20 ohms, and this also 5 ohms and 15 ohms is becomes 20 volts, and 40 ohms and some voltage, that is 20 volts, 25 volts is there. This is the after source transformation we are getting the circuit. Now by applying superposition theorem, what will happen to this? In this 25 volts source set to be 0, and due to this current 20 volts voltage, there is a current flowing through the 20 ohms. In actual problem is the current flowing through 5 ohm resistor, but the current flowing through the 5 ohm resistor and current flowing through the 15 ohm resistor, both are same. So that is replaced with 5 ohms plus 15, that is both resistors are in series. So we are replacing that 5 ohms, 15 ohms by 20 ohm resistor. So the current flowing through the 20 ohm resistor is nothing but the current flowing through the 5 ohm resistor. So now we are calculating this current. So for calculating this current, 20 ohms and 40 ohms both are in parallel, and this combination is in series with 20 ohms. See here, RT is equal to 20 into 40 divided by 20 plus 40 plus 20 ohms. So the total how much it will be? 33.33 ohms. We check it. Now the total current. So total current is equal to 20 volts divided by 33.33. How much? This is equal to 0.6 amps. We check for this. Now we have to find out the current through 20 ohm resistor. That is I1. So I1 is equal to 0.6 into 13.33 divided by 20. That is 0.4 amps. This is case 1. Now case 2. In the case 2, just I am replacing this 20 volts source set to 0 and we are applying the voltage 25 volts source. See here, the 20 volts source is short circuited and 25 volts is applied. Then how much here is 20 and 20 both are in parallel and plus 40 ohms. So this is equal to, the answer is 50 ohms. 20 into 20, 20 is in parallel with 20, it becomes 10 plus 40. So how much? It is 50 ohms. Then, now the total current, IT. IT is equal to 25 ohms by 50 ohms. That is 0.5. 25 by 50, that is 0.5. So now I2 is equal to 0.5 into 20 divided by 20 plus 20, that is 0.25 amps. So the total current through RL is equal to 0.4 plus 0.25, that is 0.65 amps. So like this we can solve by using a simple superposition theorem. Now I am explaining this with another example. Take another example. Find out the current passing through 3 ohm resistor in the given circuit with voltage source and current source. See here, 10 ohms and 5 ohms, 3 ohms, 10 ohms is in T network and 5 amps is connected. So according to the superposition theorem, the current I1 through 3 ohm resistor considering the voltage source only. Then the current source is open circuited. See, already discussed, the voltage source is short circuited and current source must be open circuited. Then here the current source is open circuited. What is the circuit now? This 10 ohms is open circuited and only 5 ohms and 3 ohms are in series. See here, the 5 ohms and 3 ohms are in series. 10 ohms is in open circuited. Then what is the current now? That current is equal to, I is equal to 10 by 5 plus 3. Now in step 2, the current I1 due to 10 volts voltage source and the current source is open circuited is shown in figure. That is 10 by 8 is equal to 1.25 amps. Then step 3 is current I5 considering only the current source as shown in figure 3. So by short circuiting this voltage source and we are considering this only 5 amps current source, now we have to calculate the current through 3 ohm resistor. So what is happening? This voltage source is short circuited, then 5 ohms and 3 ohms becoming parallel and that combination is in series with 10 ohms and see here the voltage source is short circuited. So by applying KCL at node X, the current passing through the 3 ohm resistor is I5 is equal to 5 amps into 5 by 3 plus 5. That equal to 3.125 amps. Hence Hence the total current passing through 3 ohm resistor is I1 plus I5, that is 1.25 plus 3.125, that is equal to 4.375. 4.375 amps. So if both voltage source and current source are applied. So if in this example, the current source cannot be transformed into a voltage source and voltage source cannot be into current. In this case, we have to do with the help of these two sources only by open circuiting the current source in one case and by short circuiting the voltage source in another case. Like this, by doing this, we are solving the current, and after that the two currents has to be added, and this is equal to 4.375 amps. So as per superposition theorem, the current passing through 3 ohm resistor when both voltage and current sources act at a time, the current flowing must be equal to 4.375 amps. So just I am checking that by using superposition theorem we are getting how much? 4.375 amps. So is it correct or not? I am going to check for this. Then without applying superposition theorem, we have to calculate the current through 3 ohm resistor. Then the both voltage and current sources acting simultaneously. Then the total current in 3 ohm resistor must be equal to 4.375 amps. Then only this theorem is correct. So now this is the circuit. See here, 10 ohms, voltage source is there, and 3 resistors, 5 ohms, 10 ohms, 3 ohms, and a current source 5 amps is applied. So in this circuit, we have to find out the current flowing through 3 ohm resistor at the simultaneously applied. So for solving the current, we are going to apply some nodal voltage analysis. See, apply the nodal voltage at node X. Then what is happening? Can you give this nodal equation? See here, V3 minus 10 by 5 ohms plus V3 by 3 is equal to V 5 amps, because the current flowing through 10 ohms resistor is nothing but 5 amps. So current is entering into X is 5 amps. That is the reason we are placing that is equal to 5. So the equation is, again I am repeating this, the voltage at X, Vx minus 10 by 5, Vx, that is nothing, that Vx is nothing but V3 here. So V3 minus 10 by 5 plus V3 by 3 plus the 10 ohm current through the 10 ohm resistor. Current through 10 ohm resistor is 5 amps, but it is in opposite direction. So that is the reason that is equal to 5. I am keeping that. Or you can write that V3 minus 10 by 5 plus V3 by 3 minus 5 is equal to 0. This another way we can rewrite that. V3 by 5 minus 10 by 5 plus V3 by 3 is equal to 5. So 10 by 5 is equal to 2, and that we can take it other side. Then how much? V3 by 5 plus V3 by 3 is equal to 5 plus 2, that equal to 7. So taking V3 common, 1 by 5 plus 1 by 3 is equal to 7 amps. So that is nothing but 8 by 15 is equal to 7 amps. V3 into 7 into 15 divided by 8. So that equal to 13.125 volts. The voltage at V3 is 13.125. Now the current flowing through the 3 ohm resistor is equal to V3 by 3. The current flowing through 3 ohm resistor is V3 by 3. That is equal to 13.125 by 3 is equal to 4.375 amps. The same as to that of previously. By applying superposition theorem also we are getting that 4.375, that is I1 plus I5. By directly applying nodal voltage analysis also we are getting the current flowing through 3 ohm resistor is 4.375, and by applying superposition theorem also we are getting 4.375. So hence the superposition theorem is proved as the total current passing through 3 ohm resistor when two sources are acting simultaneously is equal to the total current I1 plus I5 when the sources are acting independently. So this is the theorem. Theorem is solved, and I am explained this theorem with the help of the 3 problems. So what are the advantages of superposition theorem? The superposition theorem is usually in analyzing linear circuits containing 2 or more energy sources. It can be applied to test the linearity of the circuit. And it is very useful when different energy sources with different frequencies. See here I am explained with the help of only a DC sources, but it can be in AC sources with the different frequencies also it's applicable. And it is useful in analysis of amplifiers and communication systems. Now, what are the limitations of superposition theorem? So, till now we discussed about the advantages of the superposition theorem. Now, I am going to discuss about the limitations of superposition theorem. And the superposition theorem is applicable for linear and bilateral networks, but not directly for nonlinear networks. Actually, what are the nonlinear networks? See, an amplifier or oscillator or any active component is there, that is called as nonlinear network. So it says a linear and bilateral network, the superposition theorem is applicable, but nonlinear circuits we cannot apply. It can be applied only for computing voltage and current responses, but not power. It is valid for individual power responses, but not for the supplied power. It is not applicable for circuit consisting of semiconductors, vacuum tubes, incandescent lamps, etc. Because the semiconductor diodes, transistors or FET like that, any devices are non-linear circuits. So we cannot directly apply it to this superposition theorem. We cannot be applied. For example, I already told that there is an amplifier or oscillators. So in this period, we have discussed about superposition theorem and solving problems using superposition theorem and applications, limitations. So we discussed, and I am going to give some assignment problems, or you have to take down and you note down and you do for assignment. So before taking this assignment, I am giving some two quiz questions. You take that and tell me, by using superposition theorem, all non-operating voltage sources are replaced by short circuit, open circuit, with branch impedance, none of the above. See, question is all non-operating voltage sources or replaced by ఏంటది a short circuit, open circuit, the branch impedance, none of the above. That voltage source must be replaced by a short circuit. Superposition theorem is useful when a complex impedances are involved, reactive networks are involved, some branches are left open, multiple sources are involved. See, what is that? Multiple sources are involved, then only the superposition theorem is applied. Otherwise, there is a no chance. Take down the questions and redo the assignment. For the circuit given below, verify the superposition theorem by calculating the voltage across the terminals M and N. See, this is the circuit. Across the M, what is the current? See, there is a two current sources, that is 10 amps and 5 amps entering at two ports. At one port, it is 10 amps is entering, and another port, second port, it is 5 amps is entering. Now find out the 5 ohms resistor current. So in this current 5 amps is open circuited, and calculate the first thing. Due to the 10 amps, we have to calculate it, and next by open circuit this 10 amps, that it becomes 0. Then you apply the 5 amps and the current calculate through 5 ohm resistor, and then by adding these two currents we can calculate the superposition current flowing through 5 ohm resistor with the help of superposition theorem. See, by apply the node voltage analysis, that is the easiest way. Can I help again? See, by 5 amps resistor, 5 amps source is open circuited, then 10 amps only applied, but here there is two nodes are there, and 10 amps and another node VAMN, and V voltage across 5 ohm resistor. So from that we can find out the two node voltages analysis. From that we have to find out the current. Next, by open circuit 10 amps, there 5 amps is applied, then another 2 volts, 2 nodes are there, and 2 nodal equations will come, and similarly from that voltage across Mn we have to find out that. So in that way, in these two voltages are added, and then we can find out the voltage across the M and N. So by using nodal voltage analysis and by applying superposition theorem, we can find out this. Take down another question. See here. Here is it say I am giving AC circuit. Till now we studied only DC circuits. Now I am going to give some question on AC circuit. Here the two sources, that is 12 at an angle of 90 degrees and 6 at an angle of 0, both the sources are applied to this simple circuit, but it is a AC circuit. The similar case, the current flowing through 2 plus J2 is, we have to find out that. So the current flowing through the 2 plus J2, first we have to short circuit that 6 at an angle of 0. Then we have to find out the current. Same, see here also we have to apply the nodal voltage analysis. Only one node is there, and from that we have to find out the current voltage across 2 plus J2. So next, second case, we have to short circuit the 12 at an angle of 90 degrees, apply node voltage analysis, and similarly the voltage across 2 plus J2. Then once you know in the two cases the voltages, then it should be added, and the total voltage we can find out that. Once you know the voltage, then voltage divided by 2 plus J2, we will get the current. This is the hint. Take down the question. So another problem I gave here, there is a 100 volts and 50 volts both are applied to a simple circuit, and there is a 4 or 5 resistors are there, and find the current in branch AB. Find out the current across 4 plus J5. The same case last problem, so that you solve and you take down this problem. Okay, right, take these problems and solve. We'll go for the another class. Thank you.